Hello everybody, welcome back to OX Lorien. It's Wednesday, July 16th, just past midnight where I am. But today we're going to talk about a technique used to hide secret messages. And that is called steganography. So, now you probably heard of cryptography, which this falls under. And now steganography is different because you scramble the message. The goal isn't to make unreadable text, it's rather to make the message invisible, to hide the fact that a message even exists. And today we're going to look at the most common form of doing this, which is LSB Steganography. So LSB stands for least significant bit, right? And basically what we're gonna do is we're gonna have a bunch of ones and zeros, but we edit the final bit such that we have information in there. There is info in there, but it's done in such a way that there is no perceptible difference. So how does it work? So it all starts with a digital image, right? So we have an image of a person here, and an image, if you look at it, is just a bunch of pixels, right? We all know that. Bunch of pixels, right? And so each pixel has a color, right? Usually three values. It can be R, G, B, right? Red, green, blue. And basically it has different values. So this could be, say, 140, this could be 210, this could be 87, for example. And these three go on to create some kind of color, right? So this is where the magic happens. So now let's look at a string. Now look. Computers don't see 87 by itself, right? They see a string of ones and zeros. And this is binary. And every number from 0 to 255 can be represented in this 8-bit format. So now let's look at a string of bits, right? So we have an 8-bit. So this is 4, 5, 4. So here's an 8-bit string, right? And the bit on this side, this end, this is the least significant, while this is the most, right? So this one makes the most difference, while this one makes the least, and basically the least amount of impact. And if we change this, it barely changes anything. And this right here, this is our hiding spot. we can replace the last digit with the opposite, and by doing the seemingly unimportant change, we can basically hide our message in an image. Obviously, no one suspects an image, right? So basically, let's try to do this. Let's try. Okay. So we are gonna hide the letter A. In ASCII, A is equal to 65, which is equal to 0, 1, 0, 0, 0, 0, 0, 1. And this is the 8-bit string. And now you have to remember, this is only the alphabet, right? This is not RGB. This is not RGB yet. We're not talking about pixels yet. And so to hide these 8 bits, we're gonna need 8 color values, because 8 bits, and then you need 8 color values, right? And now there's different ways to do this. You can either go to 8 pixels, right? Or since there is RGB in each pixel, you could go 3 for 2 and then do 2 pixels. So basically 5, right? And for now, we're just gonna keep it simple and go with 8. So now imagine a picture with a bunch of pixels, and each pixel has its own value. And now we need to hide this in this. So basically we're going to so if there's an R value, for example, the first pixel, the R value, let's say 150, right? Which is, I believe, 1001, right? Or whatever it is. And we take the first one and then we flip it. So the last significant is now this. So LSB change, right? So now we have a 0 here. Then we go to the second one. We look at whatever this is, doesn't really matter. But we flip this, we flip that, and there you go again, LSB change. So basically you do this long enough until this shows up as this, right? So that's how you would get an A within your image. Now you might be thinking, how is it secure, right? How do people not notice? And that's the thing, you don't notice. You can try it out for yourself at the end, but basically when you have an image like this with all types of colors, if you go ahead and use LSB conversion, you still get pretty much the same image. The difference is so minute that you cannot recognize it with the naked eye, right? So that is a pretty good way of hiding your messages the next time. And you might also wonder, what is the downside for a method like this, right? Obviously this is a pretty good method, so there must be downsides, right? So firstly, this is very fragile, like super fragile. even compressing the image, like a JPEG or resize, the math changes, which means data is destroyed. That is a pretty big drawback if you think about it. And one of the solutions that's pretty widely used for this is basically a .zip file. This is a pretty effective solution, pretty easy. So there you have it. LSB Steganography. It's an easy and simple way to hide your data right under our noses, and it's a constant reminder that in the digital world, there's often more than meets the eye. Alright, that's enough digital forensics for one night, and I'll see you guys in the next one. Thanks for watching and stay curious.